Ladies and gentlemen, my speak today will be on use of data from electronic milking meters and perspective in use of other objective measurements from a Danish perspective. In Denmark, we store all data related to cattle in one central cattle database. It's, for instance, milk recording, data from slaughterhouses, data from dairies, veterinarian, and also AI data. So all these data are in one central database, and they can be used for different purposes. For instance, feed planning, feed control, pregnancy control, and so on. So you can say the Danish cattle database is the connecting element for many things. The flow in the Danish cattle database, we have the traditional data, which are related to pedigree, to milk production, to health, which are veterinarian diagnosis. It's related to calving and beef and conformation. So it's sort of a homogeneous, to some degree, kind of data. But in the recent years, we have got a new source of data. Just as an example, data from two-test electronic milk meters. It's from Lely robots and from other types of robots, for instance, for heat time system. These are automatically registered on the farm, and they describe old traits we know already, but also new traits that we haven't had the possibility to look at before. Some of these we have already on the central database, and other ones are on the way. Just to describe a few of them, we have the two-test electronic milk meters. In Denmark, 60 to 70% of all cows in milk recording are recorded with these devices. The data we collect is on milk duration, on every milking, and milk volume. Collection is done by milk recording technicians, and they visit the farm either 6 or 11 times a year. And at present, nearly 90% of all farmers are visited 11 times per year. We also have Lely robots, and in Denmark, 10 to 15% of all cows are milked in a Lely robot. Today it's closer to 15% than 10%. We collect data to the database and has done so recently, routinely, since November 2011, and before that we had a pilot collection. The data we collect are more or less the same, or all of them we have in the management system. And the collection is done by the milk recording technician at the same time as he get the ordinary data in relation to milking. And therefore, the data are collected either 6 or 11 times a year too. Then we have, in Denmark, other kind of robots, for instance, the Laval. At the moment, we have another collection of data from these types of robots. We're working on a method to collect these data, but we haven't succeeded yet. And what we want is the same kind of variables as we have for Lely. Then we have the heat time system. At the moment, the heat time software is integrated in the Lely system. So at the moment, we get in activity data and rumination data from Lely robots. However, in Denmark, we have more than 1,000 systems, the standalone system at heat time. And we would like to have these supplementary data to the Lely robots in the database too. We see possibilities. If we get a new version of the heat time system, it might make it possible to collect these data through a milk line in Italy. But as stated, the procedure is not yet determined. Now, when we have these data in the database, we have to use them, as the previous speaker has told. And we see management opportunities to exploit. For instance, if we have this farmer, he has a Lely robot, but at the same time he registers the traditional data. And we believe that using these two types of data in combination will add extra value to the farmer, giving him better opportunity to take the right decisions. So it has a value to the individual farmer having this system. But also we see breeding opportunities to exploit. For instance, most farmers perhaps do not have this equipment, but they have the traditional registration. Some farms have robots or some other kind of equipment, and in combination we believe that we can make more genetic progress, which will be benefit to all farmers. We see very many advantages with this data from electronic equipment. For instance, there's registration that expose new traits we don't know already, but also they give complementary information about existing traits. Furthermore, in many cases we have a repeated measurement, we have objective measurement. Today, many of the observation or the registration we have in the database are made by, for instance, farmers, and well, they might be kind of subjective. Also, we have measure of all cows and milk, and we have measure over more lactation. In the rest of my speak, I will try to mention some example of use of these new types of data. Some of them we have implemented, other ones we have analyzed, and again, other ones we will look at in future projects. I've tried to divide these examples in two groups, either relating to breeding or to management. And for breeding, I'll tell you a bit about milking speed, where we have implemented data from the automatic milk meters, and we have analyzed data from the Lely robots. For confirmation, we have also analyzed data from the Lely milking robot. And then we have a future project in relation to health traits and feed efficiency. For management, there might be a variety of uses, but today I'll only mention optimal time for insemination, which is a future project. If we start with milking speed, then breeding values today in the Nordic countries are based on assessment by dairy farmers, either done in Denmark, Sweden, or Finland. And the reason why is that we estimate breeding values across borders in the Nordic countries. Furthermore, we use registration by milk meters. We only have these data in Denmark. Data from milking robots are not included yet in genetic evaluation, but I'll show some results later. The traits we're dealing with in relation to milking speed is farmer assessment on a scale from 1 to 9, mostly from first lactation cow, and milking speed of the individual cow is compared to the rest of the herd. For milk meters, we use fat plus protein flow, and it's calculated by the mean of milk yield per test day and fat and protein content from milk recording. Our intention is that for Lely robots, we will also use fat plus protein flow, and for milk yield, we'll use a moving average per test day, and also use the fat and protein content in the milk samples. We have made some initial genetic analysis for flow or for milking speed. In the left side, you can see we have flow based on milk robots, Lely, assessment by farmers, and flow by electronic milk meters. And the heritabilities are the next column. It's 0.63 for flow when we have data from Lely robots. It's 0.20 from assessment by farmers, and 0.41 when we have flow from milk meters. So as you can see, the heritabilities are higher when we use flow, even though in this case we only use one registration, the first registration in first lactation. And of course we have the possibility to use more data. Even more important is that you see in the right-hand side, I have the genetic correlation, and as you can see, they are above 0.90, which indicate that these traits are more or less the same, describing the safe biological trait. Turning to auto confirmation, well, auto confirmation is already evaluated today. In Denmark, we have 8 experienced classifiers, and they classify around 130,000 Danish cows per year, where the majority of our cows in first lactation. And we have looked at the possibility to apply information on tip of the tit coordinates from Lely robots in genetic evaluation. What we have is we have the tip of the tit in a 3-dimensional system, an X, Y, Z coordinate, and on the basis of that, we are able to calculate the distance between front tits, the distance between rear tits, also the distance between front and rear tits. It's not a trait we classify today. We can have a measure of udder balance and udder depth. We have made some genetic analysis. In the left-hand side, you have the traits, and the next, I have the heritabilities based on tit coordinates. And as you can see, they are on from 0.40 to 0.65, so they're rather high. They're higher than the heritabilities we have when when the traits are based on classifications where we have heritabilities from 0.20 to 0.40. And also very important is that the genetic correlation is high. It's also above 0.90, which also indicates that it illustrates the same biological traits. Now I'll turn to two group of traits we'll look at in the future. In the Nordic countries, we estimate breeding values for udder health and metabolic diseases beside some more diseases. Today they're based on veterinarian diagnosis. They have rather low heritabilities because these measurements are to a very high degree influenced by management decisions. For instance, if a cow, how skilled a farmer is to notice a cow is sick, and also his willingness to call the veterinarian. We have an idea that perhaps we can get a more objective measure of if a cow is sick or not by use of milk yield per quarter, weight change, rumen activity, perhaps conductivity. So we hope and expect by combining these traits, we'll have a better measure, higher heritabilities, and more genetic progress. Another very important trait is feed efficiency. Today we have registrations of feed efficiency from researchers. These registrations are quite expensive. We only have them in small scale, and this perhaps makes it not a feasible way to get genetic improvement. So we are very eager to look at indicators of feed efficiency, and some potentially interesting ones could be body weight or rumen activity. And indeed, in this area, knowledge is needed, and therefore we will have a project from 2013 and onwards in this area. Then turning to management, we would like to look at optimal time for insemination, and the idea is again to combine all available registrations to improve the rate of pregnancy when inseminating. Today we know that there might be more factors influencing the success of an insemination. For instance, the daily milk production. If a cow has been sick and treated just before inseminating, and also we know that the relative weight loss has an effect. And there might be other factors too. So we like to make a tool for the farmer, telling him what the chance is of insemination, or in other words, when he should start inseminating and when he should not do it. So going to a conclusion, well, we have registrations. They're collected from milk meters and from daily robots today. We believe that more new data sources will follow in the future, and we need to exploit these new data both in management and in breeding. The status is, at present, well, we have implemented some of these registrations, we have analyzed other, and where we have found quite promising results, and we'll look at other again in future projects. Now going specific for flow, the heritability for flow and assessment are high, but we see the highest heritabilities for flow. And we see high correlation between traits, the different traits, which mean they illustrate the same biological trait. And we see possibilities in using flow from Lily robots in breeding values for flow or for milking speed. We see a limited effect for bulls because we already have many observations for bulls. However, we see an effect for cows from AMS herds where particularly flow is very valuable. So our plan is to include data from Lily robots in genetic evaluation for milking speed. And lastly, conclusion for udder confirmation, we have higher heritabilities when we use TIT coordinates, higher than when we use classification. And we have high genetic correlation between the different measurements. So our plan is to include these TIT coordinates from Lily robots in the genetic evaluation. And lastly, I'll thank you for your attention and draw your attention to our ICAR technical workshop in Denmark in 2013. Thank you very much.